Let me know. Let me know if you guys can see my screen.
Yep, it's up.
All good. All good. All right, guys. Well, guys, we're moving on, right? The last chapter we spoke about was a combination of chapter 15 and 16 because per you guys' request, you guys wanted to jump to, you guys felt like you were ready to discuss layer 3 from a CCNA standpoint. So we spoke about routing, we spoke about routing concepts, routing preferences as it relates to a router as far as the decision that it makes before it routes a packet for a specific prefix, right? And so a few things we went over, and of course, for those that wasn't in the session last time, you can look at the video. It is on the YouTube page. Makivia, Antoine, and Nick did an awesome job in the last session. So this is a continuation, right? We're going to take it a little bit further, right? And so this chapter, right, in the CCNA book, right, official cert guide book, right, it is called IP routing in the LAN, right, in the local area network. Okay, so let's go ahead and jump right on it. Right, and so this session is going to be breaking up into multiple sessions, right? So of course, routing within a local area network, there's different ways to do it, right? I'm sure if you guys, for the people that already got their CCNA, and for the people that's learning about the CCNA already, I'm sure you guys know there's more than one way to do something. Okay, so I'm going to go ahead and discuss the first way to do it, right? And the following sessions, probably 3 or 4 more sessions that'll discuss how to do routing within a local area network. Okay, and just for discussion purposes, right? Like before, when I say a router, right, I'm talking about layer 3. If I say a switch, I'm talking about layer 2, right? Unless I say a multi-layer switch, which means, of course, a switch that's doing both layer 2 functions and layer 3 functions, then, of course, we'll have a discussion. We'll do that configuration lab, etc. Right? And so I got good feedback from the last session that we had. You guys like the format, so we're gonna do the format the same. We're gonna go over the theory, then we're gonna hop in the lab, show the differences, and we'll be done. Okay? So VLAN routing with 802.1q trunks, right? And so couple of ways, right? Couple of ways to do it. Of course, you guys see the picture, but let's talk about it, right? So there's four different categories, 4 different ways to go ahead and do this, right? We can use a router, right? One router has a interface on it, right? There's a cable connected to it, right? And that cable is dedicated to each VLAN, right? On the switch, right? Is that efficient? That's up to the person that is the administrator, the engineer, etc. Right? Because the great thing about Cisco or any infrastructure device, it's going to let it do whatever you want to do. You're the design, you're the architect, etc., right? Now, what's the other category, right? What's the other way that we can configure VLAN routing with 802.1q trunks, right? We can go ahead and use a router, right? Layer 3 device, right? With a VLAN trunk connecting to a switch, right? Known as router on the stick, right? And that's what we'll be talking about today, okay? And I'll show you an example. We'll hop in the lab, etc. Right? The last 2 examples, right? We can use, of course, a multi-layer switch, right? And use switch virtual interfaces, right? Basically, layer 3 VLANs, right? We can create layer 2 instance, right, for that VLAN, and we create the layer 3 interface for that VLAN as well. So that's how we can do routing with 802.1q. Also, of course, the last but not least, the other category we can use 802.1q is to use a multi-layer switch with routed interfaces, right? Which means, of course, it'll be physical interfaces that are dedicated and have IP addresses on those physical interfaces, okay? But let's talk about the fun one first, right? Routing on a stick, because of course you guys it'll be more prevalent. You guys will see that one and the third one that I mentioned, which is the multi-layer switch with SDIs. Okay, so as you guys can see this diagram, right? We have routers, right? We have our layer 3 devices. We have our multi-layer switches, right, on the left, and we have our layer 2 switches, right, on the right, right? And so on the right is how our topology is going to look today, because that's how we're going to configure routing on the stick. It's going to look like this topology, right? And so you guys are probably thinking, right? Because I've already told you guys, right? Well, Dave, based on the OSI model, right? A router is dedicated, right, to layer 3. Okay, it's dedicated to layer 3. How can it go ahead and involve itself with a layer 2 technology like trunking? We're going to go over that today. Okay, so here's how the diagram looks, and I'm going to go ahead and break it down to how it works, right? And so, luckily enough, right, the guys at Cisco, they went ahead and said, hey, right, having multiple interfaces, right, multiple physical interfaces that's dedicated to each maybe VLAN, right, that we configure on the switch, right? We can do it, we can configure it. Is it efficient? Absolutely not, right? We don't want our customers to buy 15 routers, right? 15 routers to handle 15 VLANs, right? Right? We don't want them to do that, or how many VLANs, how many interfaces a router has, right? It's not efficient, right? We'll make the money, but we won't have any customers. They'll go to somebody else. So how can we make this work for them? So that's when they created technology, ROAS, or router on a stick, to where we can go ahead and meeting the stick, right? We can have, let me go ahead and get my pencil, right? There we go. Yeah. No, it's a bad color. There we go, right? No, not that color. There we go, right? So we can have one physical cable, right? Going from the switch to the router, right? And what is it doing? Because what do trunks do? They carry multiple VLANs on a single link. You understand? And so they enabled that layer 3 device to participate in trunking, right? In that layer 2 technology, right? To help out their customers, to help out these small businesses, to say, hey, we know you guys probably want to, isolate different parts of your network. You guys don't want to buy a whole bunch of routers. Here we go, right? And we're going to take a look at a packet capture as well, so you guys can actually see what's going on. Okay, you guys are going to configure it with me as well, right? So that's what it does, right? It's going to associate a VLAN, right? A VLAN, maybe the IP address for a VLAN, if you're looking at the diagram, right? Associate maybe VLAN 10, right, from the layer 2 standpoint, to a layer 3 instance on the router, right? So it's going to be interface, right? Gigabit 0/0.10, which means VLAN 10 on the router, right? That's not how you program it all the time. Of course, configuring what the interface name is totally up to you. The sub interface name is totally up to you. But as you can see, we can also configure another sub interface that sits below a physical interface, right? And how does it work, right? Well, as you guys can see, right, it's passing traffic for both VLAN 10 and VLAN 20 between the router and the switch, right? So if Nick's department, right? Let's say Nick works in the NOC, right? So he's on VLAN 10, right? And Makivia works in VLAN 20, right? And she works in the SOC, right? And so they went ahead and came to the architect, Antoine, and said, hey, we want to go ahead and we both want to, communicate out to the web, right? Wherever we're building the NOC and the SOC, but we want to isolate the SOC network and the NOC network. This is how Antoine can do it, right? From the layer 2 perspective, and also the layer 3 perspective, right? So traffic is not flowing through both the NOC and the SOC, okay? So this is where routing on the stick comes into play, okay? Let's keep going. Any questions so far? And it'll all make sense as far as me talking about the sub interfaces, trunking, et cetera, whenever you guys see me configure it, and you guys also see the configuration that we do. Because of course we're going to do the configuration together. I didn't do any pre-config, right? I did boot up the devices, gave it a host name, but there's no pre-configuration. We're going to do it as you guys see me. So it's recorded and you guys can come back. And also so you guys can ask questions, right? So this slide, right? You guys can read. These are the 3 steps on a router that you can do to go ahead and configure routing on a stick, right? Or router on a stick, as they call it, right? the big thing here is there's two ways you can configure it, right? If you configure router on a stick, right, you can either configure it with a IP address configured on the physical interface, okay, that's dedicated to that native VLAN, right? That that's negotiated between the trunk, right? Because there has to be a native VLAN for untagged traffic to pass, right? And we'll talk about that in the future. Just keep following with it, right? Whether it be VLAN 1, VLAN 90, whatever the native VLAN is between that trunk, between those two devices, they need to agree, right? So you can either A, go ahead and configure that physical interfaces with the IP address and then configure sub interfaces, right? And that physical interface, right, that has an IP address on it, that'll be your native VLAN, okay? But the other way you can do it is not to configure that physical interface with an IP address. You can just start configuring the sub interfaces and tell a certain sub interface, hey, you are the layer 3 instance for this native VLAN, okay? Whether it be VLAN 1, cool. Here's a native VLAN. I'm going to say native VLAN right here. Boom. So now any untagged traffic, right, that's coming, maybe Antoine has a guest. Antoine, Mikevian, and Nick has a guest that comes into the knock and sock. It has to plug in. We don't want to give them access to the network. We just put them on maybe VLAN 1, okay? They get an IP address for VLAN 1. They can still get out, but they're going through that native VLAN sub interface, right? That's not associated with a proprietary VLAN like VLAN 10 or VLAN 20 or what have you, okay? So let's keep going, okay? So here's an example, right? Exactly what I showed you guys, right? So one of the ways to do this, right? No IP address on the physical interface, but there's IP addresses on the sub interfaces. So you can do this, right? It is possible to go ahead and do that on that router. Let's keep going, right? So quick note, right? Just like I told you guys briefly, but please take note of this, right? Cisco is going to let you do whatever you want on a device, on a firewall, on a switch, on a router, whatever they give you. They're going to let you do anything. Give me 1 second. I think there's a question. To confirm, the native VLAN is configured on the sub interface, and to confirm the native VLAN is configured on the sub interface and not the main interface. I'm confused. If it's native, why is it configured on the physical or the main interface? Good question. So, and thanks, Makini, for that question. So with that, right, that's why I was saying you configure it in two ways. How many sub? Dre, I'll get to your question in one moment. So, Makini, there's two ways to do it, right? And so you'll configure, right? Let me go back to the previous slide. You'll configure, right? Let's say we configured it here, right? We have our two sub interfaces with no IP address, no layer 3 instance on the physical interface, right? We can configure whatever the native is by putting the command, and I'll show you guys, native VLAN, right? Or whatever the command is under the sub interface. But you can also configure that native VLAN, right? That native VLAN instance, right? Layer 3 instance on that router by just configuring that physical interface, right? Because they're going to be a layer 3 instance. It's not going to have a VLAN associated, right? Because it's not going to have that .1Q command there. You see what I mean? So what that means is the router is going to say, hey, there's no layer 2 instance associated with this interface like a sub interface does. We can go ahead and just pass any other traffic out this interface. Does that make sense?
Yes, it does. Thank you for explaining that.
Oh, no biggie.
I'm still confused here with that. What you call it? I'm trying to wrap my head around the fact that yes, you can also assign interface, a physical interface to a native VLAN, but also I guess on a router, I would say. But also you could do that with a sub interface, assign the same sub interface to the native VLAN on the router.
Okay, so what's your question?
I guess my question is that how would that be possible at the same time?
Configuring them both at the same time?
Correct.
Yeah, you can't. It's either one or the other.
Okay.
Yeah. It's either one or the other. You're gonna confuse the router, right? And if I'm not mistaken, it may not let you do it. We can test it out in the lab, but it may or may not let you do it, right? But even for routing purposes, right? You don't what the sub interface allows, right? How I can sum it up, and I learned from my mentor a long time ago. Configuring the sub interface, it enables the router to work in both layer 3 and layer 2, right? With just a physical interface on a router, not a sub interface, it only can operate at layer 3. Okay, so there's no layer 2 tagging anything on just the physical interface, right? So that traffic that it receives, it's not going to be able to read that layer 2 header and trailer. Those sub interfaces will. Does that make sense?
Wait, you said that if I assign let's say I assign a physical interface on my switch to the native VLAN, and I want to go ahead and route traffic or packet from that native VLAN from that switch to the router. Why I just blacked out and forgot what you just said.
It's all good. It's all good, right? So let's rewind, right? So
yeah,
two main things to understand about ROAS, right? Router on a stick, right? So with the router, because we're configuring this on the router, right? A router is mainly a layer 3 device. What does that mean? It's physical interfaces. You're configuring a layer 3 IP address. There's no layer 2 configuration. You're not putting a VLAN. You're not associating anything on that physical interface. Why? Because it's a layer 3 device. Now, right? Here's where sub interfaces come in, right? They enable that router to handle and to talk via layer 2, right? To be able to read those Ethernet, right? Those layer 2 headers and trailers, right? Mostly the header, right? Because that's where the VLAN ID is at. And it's going to say, oh, this is traffic from the switch for VLAN 10, right? For Nick's network. It needs to go to my Kivia's, right? Network, right? To VLAN 20, right? The router is able to read layer 2 and layer 3 because it has that sub interface instance there. That's what the sub interface technology can do. But a regular router, a regular physical interface can only read layer 3, right? So there's no tagging. It can't read a layer 2 instance. It can't read those layer 2 frames that says, hey, this is for this VLAN, this is for that VLAN. Does that make sense?
Oh, okay, so all right, I think I got it now. So if a switch has a tag frame in their VLAN and it's trying to communicate to the router, the router won't understand it if the router won't understand it if the switch is sending it to a physical interface, but if it's a sub interface, then it would accept it.
That's correct.
Okay.
That makes sense?
That makes sense.
Okay. All right, let's keep going. All right, so before we left off, right? Real quick thing about configuring ROAS, right? Is like I told you guys, Cisco is going to let you do whatever you want on these devices, right? And so what this excerpt is saying, and I thought it was good to take a screenshot of this and show you guys, right? Whenever you're configuring your sub interfaces, right, on your routers, or people do still, I believe ISP still do use physical routers, so you guys will probably encounter them to this day, right? Whenever you do configure it, Cisco does, I don't even want to say recommend, right? They say you should, right? Go ahead and make the sub interface match that VLAN ID, right? So that's it, right? So just keep that in mind whenever you're configuring, right? And so Swan and Mykevia, hopefully this makes sense. Dre, I'm going to come back to your question. I haven't forgot about you. So this answers your question, both of you guys' questions, right? So configuring ROAS, right? If you configure the IP address command on the physical interface, but without an encapsulation command, the router considers the physical interface to be using the native VLAN. On the flip side, configure the IP address command on the sub interface and use the encapsulation .1Q VLAN ID native subcommand to tell the router both the VLAN ID and the fact that it is the native VLAN. Does that make sense, guys? Two ways to do this. Any questions?
I'm gonna have to reread that again.
Reread it again. So let's read it again. Right?
All right.
So the first point, right? The first point, it's talking about a physical interface, right? That physical interface on a router, right? If you configure the IP address, right, on that physical interface on that router, right, but without an encapsulation command, because you won't be able to do it anyway, the router is going in its brain, in its CPU, it's going to say, I cannot perform anything at layer 2. I can't read anything at layer 2, right? So I'm going to assume anything that's coming to me is untagged, doesn't have a VLAN associated. So this interface, this IP address, this subnet is the native VLAN. No matter what I configure, but this is the native VLAN because I can't read layer 2. If I'm the physical interface, I can't read layer 2. Whatever's coming to me, I can't even read that layer 2 header. I can't read whatever the VLAN ID is. But if I am the sub interface, if I create a sub interface on this router associated with this interface, right? No IP address on the physical interface, but an IP address on the sub interface, right? Because that sub interface is a virtual interface. It's just like an SVI on a switch, right? But me creating that sub interface, right? And saying, hey, I'm still a router, but as soon as I put that encapsulation .1Q command, I'm saying this sub interface, hey, you can go ahead and start reading those packets that you get. You can start reading those layer 2 headers, right? So of course I'll put that encapsulation .1Q command, but I'm also saying, hey, for a specific sub interface, I can have 10 sub interfaces, but maybe for sub interface 0/0.1, right? VLAN 1, I'm saying for that sub interface is my native VLAN with that command. And of course, I'll show you guys, because I created a lab that will do both. Okay, so you'll see the packet capture, okay? All right, so let's keep going. Okay, here's another example, of course, that you guys see. Of course, they can go ahead and configure the IP address on the physical interface, right? And let's take a look at the top, right? Let's take a look at the top screenshot. There's no native VLAN configured, right? The native VLAN command doesn't exist. Why? Because from that last point, it says if an IP address is configured on the physical interface, but without the encapsulation command, the router says, hey, this is the native VLAN, right? So maybe VLAN 10, right? Is this physical interface how it connects to the switch? That's the native VLAN without even saying it's the native VLAN on the router, right? If we look at the second option, right? Adding the native keyword command, right? We can go ahead and create a sub interface, right? For VLAN 10 and say, hey, encapsulation .1Q 10, but VLAN 10, right, is the native VLAN. Then add the IP address there. Because if you can see, the top and the bottom, they have the same IP address. We just moved from using the physical interface to using the virtual sub interface off of that physical interface, okay? It'll make sense whenever we do the lab, okay? So let's keep going, right? Whenever we go ahead and configure these sub interfaces, like configuring an interface, a connected and a local route is going to be added to your routing information base or your routing table. Okay. All right. So, real important thing to understand about sub interfaces and routing on a stick. Okay. Let's say we don't configure a IP address. We're going with the second option. We don't configure an IP address on the physical interface, but we configure it on the sub interfaces. But those sub interfaces are attached, right? They're working off of that physical interface, as you guys can see here if you look at the show IP interface brief command, right? If we shut down that physical interface, those sub interfaces are shut down. If we enable the physical interfaces, the sub interfaces come up. Does that make sense?
Yep.
Yes.
Okay.
Yes.
Okay. All right. So, as you guys know, right? As soon as we, enable ROAS, right, routing on the stick, right, we configure sub interfaces on that router. The router, now you'll be able to go ahead and do a show VLAN commands, right, to see what's configured, see the layer 3 instance, layer 2 instance, et cetera, right? And you'll see in action, as you guys can see in the screenshot, I know it's small, that the router is now, even though it's a layer 3 device, it's participating and working in some layer 2 technologies. Okay, let's keep going. Okay, and so here's a quick tidbit, right? We're not going to jump into this because we're going to figure our lab. We're going to come back to this, right? And this is discussing troubleshooting ROAS. Okay, let's go ahead and jump into the lab. Okay, let's stop sharing. All right, so Dre, coming back to your question. You said, is there a limit of how many sub interfaces that can be created on one interface? Dre, let me get you Cisco's documentation, because I believe it's per device, right? Per software, et cetera, et cetera. So I don't want to tell you the wrong thing, okay? Let's go ahead. All right, so let's go ahead and share in my lab. All right, can everybody see my lab? Everybody good?
Yes.
Yeah.
Okay. Okay, perfect. Perfect. All right,
Yep.
so let's go ahead and start having some fun. Okay, so here's what we'll do. Let's go ahead and start labeling stuff, right? So
David, can you just zoom in just a little bit? Just a
sure,
little bit.
sure. Give me 1 second.
Thank you.
Go ahead. No, it's all good. Let me how's that work? All good?
Yes, that's better. I'm
Okay.
not sure if both were needed to, be shown at the same time.
No, it's all good. It's all good. All right. So this first one, right? We're gonna do the option with the physical interface, right? Having an IP address. Whoops. Let's close that. All right. All right. All right. So this topology, right? We have one router, we have a switch, right? That's connected to that router using one physical link, right? And we have multiple computers hanging off this switch. As you guys can probably assume, these PCs are going to be placed into different VLANs, okay? We're going to test router on a stick, right? And so what are the VLANs? Let's go ahead and start marketing. Oops. So let's do VLAN 10, okay? VLAN 20, and VLAN 30, okay? And so VLAN 10 will be on the physical interface, right? And VLAN 20 will be on the sub interface, okay? All right, let's go ahead and configure. All right, so we're on R1. Let me know if everybody can see my screen.
Yep.
Okay, let's go ahead and reset this terminal. There we go. All right. So of course we want to go ahead and configure this device, right? Just as a refresher, as soon as we log into a Cisco device, we're brought right into user exec mode. You can tell by seeing the greater than sign. As soon as we type the word EN or enable as for its short term, we can go, it'll bring us to privilege exec mode, right? But if you guys remember, we want to go ahead and make changes to this device. The only way we can make changes to the device is to get to global configuration mode so we can make changes to the entire device, right? Keyword global configuration, right? So to get to global configuration mode, right, we're going to put in configure terminal, right? So we're here, right? And now we want to go ahead and we want to configure our physical interface, and we want to configure our sub interface, right? So if we can see, pull up my pencil. Our physical interface is gigabit 0/0, right? So that's the interface we'll be using. Okay. So let's go ahead and hop in this router and start configuring. Okay. So interface, right? Gig and 0/0. Okay. Let's give an IP address for VLAN 10. Oh, let's do 10.10.VLAN10.1. Okay. We'll give it a /24. And let's enable that interface because by default, router interfaces are shut down, all right, or not enabled. So we need to go ahead and enable it. And we enable it by doing a no shut, right? And of course, we'll get a syslog message across the screen that says, hey, your interface is enabled, right? And the link is up, right? Layer 2 is up and layer 1 is up. All right. So we're good there, right? We're good there, right? Let's go ahead and verify that. Show IP brief. Perfect, right? So layer 1 and layer 2, it's showing up, right? Status is telling us layer 1. Protocol, of course, is telling us layer 2, right? So gigabit 0/0 is up, right? Let's go ahead and configure the sub interface, right? How do we do that, right? So how we would do that is we're using the interface that's hanging off of 0/0, right? These sub interfaces are going to be tied to 0/0. So we're going to put interface gigabit 0/0.20. Okay. Let's take a look at this. See it? So the router knows, oh, okay, you just created a sub interface. Okay. Versus if it's just a physical interface, you just see IF. Okay. So the router knows, okay, this person is configuring ROAS or routing on a stick. Okay. All right, let's go ahead and configure, right? Let's do our command encapsulation, right? Let's do the question mark, right? You guys know I love that, right? So routing on a stick is associated with .1Q. Of course, you can use ISL. You can do priority tag. That's a different topic. That's CCNP level, but we are doing .1Q, right? So we're going to put that, right? And then we're going to go ahead and put the VLAN ID, okay? So the VLAN ID for this is 20, okay? And then we are going to put the IP address, right? So 10.10.20.1, right? 5.5.5.0, okay? All right. And I don't believe you have to no shut it. It's just by habit, I do that. So that's configured, okay? Let's go ahead and reset the terminal, right, to clear out the screen. And let's do another show IP interface brief so you guys can see the difference, right? So you guys see, right? It is hanging off gigabit 0/0, right? And, right, this sub interface, it's up, right? Let's go ahead and configure VLAN 30 and go ahead and get that done, okay? So interface gig 0/0, so same thing, .30, okay? All right, so let's do our encapsulation command, .1Q, and that VLAN is going to be 30, right? So that's there. Now, we'll go ahead and configure layer 3. Whoops. IP EDR 10.10.30.1.5.5.0. Okay. By habit, I always do the no shut. All right, so we're good, all right? So let's do, perfect. All right, so we have our other VLAN here, right? A layer 3 instance, right? Layer 1 and layer 2 works, okay? So let's go ahead and save that config. All right, boom. All right, so let's go ahead. There we go. Let's go ahead and hop into switch 1. There you go. All right, let's go ahead and reset the terminal. We're in user mode. We need to go ahead and get to privilege exec mode. All right, we're here. And let's go ahead and make those changes, because what we need to do on this layer 2 device, it's only operating at layer 2, this switch. So we need to go ahead and first create the VLANs, then configure the trunk. Okay, so let's go ahead and do it, right? And what's that interface, right? That interface should be gigabit 0/0 on the switch as well. Okay, so let's go ahead and do that. So interface gigabit 1 second 0/0. Right, switch port mode trunk. Oops, this is, and forgive me guys, this is the old switch, right? You don't have to do this on the older switches, but you need to go ahead and put, I just need to go ahead and put a command that enables 802.1q, okay? And there we go, encapsulation .1q, there we go. You guys don't need to remember this for this Cisco exam. This is just an old image of a Cisco switch. All right, so we went ahead and did that. Now we can do switch port mode trunk, boom. All right, so we created the trunk, all right? And now let's create our VLANs, all right? So we are going to do VLAN 10. Okay. VLAN 20. Go. Right? And we're gonna call this aside. Now, right? What we have to do is we need to go back to our physical interface and say which VLAN is our native VLAN, right? So let's go back to interface 0/0. Let's say switch port trunk, right? Native VLAN 10. Okay. All right. So we have that configured. All right. So now let's go ahead and reset. Well, before we reset the terminal, we got a few things to do. Let's go ahead and put some of the interfaces in VLANs, right? Okay. So switch port, access, VLAN, put this in 10. And I think it's gig 0/2. Put this in 20. Exit, I think it's gig 0/3. Put this in 30. Boom. All right, so we have that configured. All right, let's do some verification. All right, let's do a show interface trunk, right? And so let's confirm a few things, right? So gigabit 0/0 is our trunk hanging off of that switch, right? We're doing 802.1q, right? And we did configure, right, the native VLAN to be VLAN 10 for this trunk, okay? For the interface that has a trunk configured, right? We're allowing all VLANs, but the current VLANs configured is 1, 10, 20, and 30, okay? So we have that configured, we're all good, right? Last but not least, let's go ahead and let's go ahead and configure these PCs with some IP addresses, okay? Let's go ahead and move that over. Yes. So IP 10.10.10.50. There we go. And give it its gateway. Perfect. All right. So we got that there. All right. Let's go ahead and configure PC4. IP address, and that's in VLAN 20. 10.10.20.50. 55.55.55.0. All right. 10.10.20.1, which is its gateway. Okay. All right. That's good. All right. Last but not least, figure this for VLAN 30. P 10.10.30.50. 5.55.0. 10.10.30.1. Okay. All right. So that's set. All right. So let me go ahead and clear the markings. All right. So now we're going to go ahead and do a capture, right? Because I want to see all the traffic so we can see, right, from layer 2 perspective, what's tagged and what's untagged. Okay. Let's give it a moment to come on up. Oops. See how long it takes. And even if I have an issue with Wireshark, we can still see the matches of traffic. See how that looks. Okay. All right. So there must be a lab error with the capture, with the packet capture. So we'll fix that in a second. That's no issue. Let's keep going. All right. So if I go ahead, PC3, right? Let me zoom in. Zoom in again. There we go. Right. And so reset. Okay. And if I go ahead and ping its gateway, right? Theoretically, it should work. Right. Okay. So we're getting pings, right? We're getting pings. That's working, and that's working good. Now, if we go back, right, let's dissect this. Let's go back to the switch. Go back to switch 1, right? So that interface, right? Let's do a show run interface gig 0/1, right? That's where PC3 is hanging off of, right? That is in VLAN 10, okay? And if we see, we do a show run, we tell our native VLAN is VLAN 10, right? And so what that means is there's no identification, right, of that packet coming from PC3 to get to the router of saying which VLAN it's in, right? What the switch and the router negotiated on is said, hey, this is the native VLAN, VLAN 10, but we're not tagging that traffic, right? We don't know if it's VLAN 20 or what have you, right? And so if I go ahead and go to PC4, right? I go to PC4. Let's go ahead and clear this out. And I go ahead and, all right, and I try to ping my gateway, right? Now, VLAN 20, right? that is not associated, right? That's not a native VLAN, right? So if I go ahead and look at that interface that PT4 hangs off of, so we can be 0/2, that's in VLAN 20, all right? So we confirm layer 2 right there, right? And of course, we confirmed that, of course, all VLANs are allowed on gigabit 0/0, which is the uplink to the router. Let's see if I can ping it. Okay, pings are working, right? But let's do an experiment, right? We can't do packet captures, but let's take a look at the router. What happens if we do this? Okay, so what I did, I just shut down the sub interface, right? Let's see if that change reflects. Okay, so I shut down, right, the layer 3 instance for VLAN 20, right, on the router. Let's see if I can ping. Right, I'm getting failed pings. Okay, so even without a Wireshark and packet capture, we can tell, right? We can see based on theory that, right, the VLAN 20 instance, right? The VLAN 20 instance, right? If we do show run interface gig 0/0.20, right? Knowing that this is associated, .20 is associated to VLAN 20, okay? It's just, and of course, it's layer 3's identifier is 20.1. Now that I've manually shut it down, okay, we know that switch 1 gets it, right? Because that access layer port that it connects to the PC4, it is assigned to VLAN 20. All right. And when the switch gets it, it says, hey, this is VLAN 20. Let me go ahead and pass this up to all trunks that I'm allowing VLAN 20. And so it's passing that traffic, but it's not getting to it because I manually shut it down. So layer 2 and layer 3 does not exist currently, right? So let's say if I do a continuous ping. Okay. I'm doing continuous ping, it's still unreachable, right? I'm not even able to do it, right? So if I go ahead and keep doing this, all right? I do it no shut, right? I enable it. Now we see pings, right? Now we see pings working, okay? So let's go ahead and stop that. So even without a packet capture, you guys can see, this is how routing on a stick works, right? We have one physical interface, right? It has an IP address, right, for the native VLAN, right? But we also can assign sub interfaces that are associated with different VLANs, right? But let's say, right, I shut, of course, the VLAN down again, right? Is PC3, which is part of the native VLAN, will it be affected, right? It isn't, okay? Right? Because again, this is the native VLAN. Per the rule, right? Let me go ahead and bring this back over, right? Configuring an IP address to a physical interface, but without an encapsulation command. And hopefully this makes sense. The router considers this physical interface to be using the native VLAN. Okay. All right. So that's for the first part, right? This is if we configured a physical IP address on the interface on the router, right? Let's move on. Let's go ahead. There we go. What was that else? There we go. Just so I don't get confused. There we go. And boom. All right, so now let's move this down and find my mouse. There we go. All right, so let's zoom in a little bit more. All right, and let's scoop this up. All right, and let me go ahead and scoop this up. Oh, looks like Ryan is trying to join. All right, so now that looks confusing. There we go. There we go. Make it easy. There we go. All right, so let's do our second example, right? There we go. All right, so no physical interface IP. Okay, so we are going to configure all of this. All right, on sub interfaces, all right, and nothing on the physical interface. So let's see if it works. I'll load this up. There we go. All right, so same process, right? We enter into user exec mode, okay? And let's go ahead and get to global config mode because we want to make those changes there, okay? All right, so remember, right? We're not adding an IP address to the physical interface, but by default, like I told you guys, right? The router interfaces, the actual layer 3 router interfaces are disabled by default, right? For security purposes, right? So we do need to make sure we enable them, right? But first, let's go ahead and configure our sub interfaces, all right? So interface, gigabit 0/0. Oops, 0/0. And this is going to be .10, okay? So IP address 10.10.10.1.5.5.0. All right. And correction on my part, there is an order of operations. First, we need to do encapsulation, then do the IP address. So I do apologize, guys.
I was just gonna ask that.
All right. So now let's go ahead and add the IP address. Now you guys can see, of course, order operations. We first need to configure layer 2 on the sub interface, then configure layer 3. Okay. Do apologize, configuring that the other way around. So once we do that, let's go ahead and we're not going to do a no shut. We're not going to do that. Okay. We are going to, well, just for the heck of it, let's go ahead and do it. Okay. All right. That's there. Now let's go ahead and do the other one. All right.
Hey Dave, quick question for you.
Yeah, what's going on?
Are you configured? Or sorry, are you? Do the different interfaces already have the VLANs assigned to them, or are you doing that later?
So that's what we're configuring now, right? So with the encapsulation, I'm not sure if you were in during that time. So what the encapsulation.1q command does, it associates the VLAN to the physical
That
interface.
.10, right?
Mm-hmm.
Gotcha. Okay, I'm following you.
Okay. All right. .20. All right. Let's go ahead. Follow the order operations. All right. Encapsulation. .1q. 20. All right. Go ahead and add our IP address. 10.10.10. Oops. .20.1.5.5.0. All right. So we got that. Let's do a no shut. Keep with it. Go. And now let's do our last interface. All right. .30. So encap. .1q30. All right. And let's add our IP address, right? 10.10.30.1, 55.55.55. Okay. Save, right? And let's go ahead and go to the switch. All right. Go ahead and blow this, right? And when you configure the trunk and when you configure the downlink ports to be part of specific VLANs, right? So let's get out of user exec mode. Let's go from privilege exec mode to global configuration mode, right? So we're here. Let's take care of the trunk first, right? Interface gigabit 0/0. Remember, guys, what I'm doing first, you guys do not have to do on any newer switches, all right? Because it's automatically enabled by default, okay? But this part, we do have to do, right? Tell the interface which mode you want to run it in, either a trunk or access, right? We're going to make this a trunk, right? So that's configured, okay? Now let's go to our downlink ports, okay? So interface gig 0/1, right? We're going to go ahead and put that in VLAN 10. Switch for access. And I'm not going to create the VLAN in global config mode. I'm just going to create it off the interface, right? Okay. So created the VLAN 10, 0/2, right? Put this in VLAN 20, okay? Perfect. All right. So that's configured, right? And so let's do it. Go ahead and do some confirmation, right? So if we do a show VLAN brief, we can see my VLANs have been configured, right? Default names to them, different than before, but of course my VLANs are configured, right? 10, 20, 30. All right. So, and of course I have interfaces, the interfaces are associated with them. Last but not least, let's go ahead and configure these devices, put them in that subnet. So first PC8, that's going to be .10. So let's do 10.10.10.50, 5.5.5.5.0, 10.10.10.1. All right. Perfect. We're good. Let's do PC9. That's going to be in VLAN 20. Okay. IP 10.10.20.50. There we go. Put the subnet mask 10.10.20.1. All right. Put that gateway. All right. And it's configured. Last but not least, let's go ahead and configure this. All right. 10.10.30.50. 55.55.0. 10.10.30.1. Okay. So all that's configured, right? Now remember, on the router, I configured these sub interfaces, but I did not enable the physical interfaces, right? Which is interface gigabit 0/0. So if I go ahead and try to ping from PC8, right? Sub interface VLAN 10, right? And I apologize. We forgot one step, guys. We did not identify our native VLAN. We forgot to put that right here. Let's go ahead and go back into global config mode. There we go. Cancellation .1Q 10 negative. There we go. There we go. All right. So that's configured, right? So we got our VLAN, right? Our destination. Let me go ahead and try to ping it, see if it works. 10.10.10.1. Okay. So it failed, right? Host not reachable, right? So this goes back to the PowerPoint of what it was saying, right? These sub interfaces are associated with a physical interface. That physical interface, no matter if on the sub interfaces I do a no shut, that physical interface reigns supreme, right? It's the king, right? We need to make sure that we enable that interface before we say, hey, sub interfaces, you guys are free to play. All right. So let's go ahead and enable that interface. Right. Let's do a show IP interface brief. Okay. And again, this is going back to the theory. Okay. There's no IP address assigned to the physical interface, but we have IP addresses assigned to the sub interfaces. Routing on a stick is still going to work, right? We have our native VLAN set for VLAN 10. That's going to handle the untagged VLANs, okay? So if we go ahead, if I try to ping, right, it's still going to be unreachable, right? Why? And this is the point I wanted to make for you guys, right? So again, we configured VLAN 10 to be the native VLAN, okay? And so if I, on my switch, right, if I said, hey, gigabit 0/1, which is what PCA connects to, if I assign you to VLAN 10, the traffic there is not going to work. But if I disassociate, do you guys think the pings are going to work now? Why aren't the pings working? Is it because of the switch? Good question. Let's take a look. What do we have here, Nick? What do we have misconfigured?
Let's see. Oh,
Reset the terminal. I got you. I know it's a lot of stuff to look at. Reset both of them. Help you guys out. And anybody can answer. So show line interface gig 0/0.10. All right. Then show interface trunk. So on the left is the switch, on the right is the router. What did I
Yeah.
configure wrong?
Let's take a look.
Is it G01? I'm at G00.
Why?
Oh, okay. So I'm looking at it, and it has one VLAN assigned to it. And if I'm not mistaken, was there more supposed to be assigned to that one port than it is?
That's what I'm gonna say too.
This is a
It looks
sub
like
interface.
20 and
Right.
30 is
This is a sub interface.
okay. Hold on.
Anybody else?
I'm just thinking, is it because it's not pinging because you shut down the switch port? So is that what
I didn't shut down the switch port.
didn't?
Mm-mm.
So you didn't?
Did you do no shut on any of them?
Nope, I just did it on a router interface. I did not do it
So
on a
should
switch
the other ones be
interface.
up as well? Or-
So they both
Got-
have to be open up because one's down on the router, is that it?
They're both up. You can take a look, right? So the uplink between The interfaces between the router and the switch are gigabit 0/0. So let's take a look. Show interface.
Interface.
Let's do show IP interface brief. Okay. So gigabit 0/0, right? Layer 1 and layer 2 is up, right? And if I do that for the router,
Oh.
the interface is up.
Are there any IPs?
We didn't put the IP address for VLANs.
I didn't.
Well, G0.
On the switch.
Yeah, none of those. All those are up, but no IP address is assigned. They're all unassigned.
So a switch that we set in our lab is going to be a layer 2 switch. Why would it need IP addresses
Okay.
when we're doing routing on a stick?
Okay, never mind. Yeah, that
Okay.
makes sense.
What is and you're close. You're close, Nick, right? As far as because of the switch. Well, you messaged me.
Yeah.
What is mismatched? What is on one side and what is not on the other?
Is it the gigabit 0/0 is unassigned, but that's on the router, and then on the switch, it's up and up. Is that it?
Nope. You're close.
Hmm.
It has something to do with gigabit 0/0.
Okay.
What is mismatched? Take your time, guys.
Oh, okay. I'm take a wild guess. On 4 gigabit 0/0 on the switch, I feel like we gotta let that port know that it's got a tag VLAN 10, 20, 30
There we
on
go.
that interface.
Nope. You're close.
Damn.
That is
You are very close. What
Alright.
is mismatched? Nick was close to saying it, and I had to take my congratulations back. He is very he was very close.
Can I try?
Is the assigned
Yeah,
on the
try.
Hold on, somebody's talking. Who wants to try?
Yeah, I'm driving, so I'm giving my best shot on
Okay.
the router interface. But
Okay.
having issues. Do the VLAN numbers match?
Okay, the VLAN's number do match. I have VLAN 10 on and VLAN 20 and VLAN 30 on the switch.
How about the
There's
IP
no
address?
VLAN 10 on the router.
They shouldn't match on both sides because the router is the layer 3 instance.
Gotcha.
Nick just was close to saying it, guys. There is a mismatch.
In the native VLAN, is that what you said, Nick? And it was
I was
30?
I was saying that on that port or interface gigabit on the switch, right? Giga Ethernet 0/0.
Mhm.
I feel like it needs something with VLANs 10, 20, 30 on the Giga 0/0.
And that's where Nick got the question wrong. So
I got one more question. How about the switch port association with the VLANs?
nope. Has nothing to do with it.
I can't see the config, so I'm driving, so I'm just guessing.
It's all good. It's all good. Markivia, you're close. There is something mismatched.
The difference I see is at 4090. Hold on. Well, I was not active management domain VLANs.
So everybody stop. Everybody stop
native?
talking. Everybody stop talking. Markivia, I want you to keep going. What is mismatched?
Okay. So on gigabit 0/0,
Okay.
are we still focused on the router? Because that's what I'm looking at.
We are focused on both. What is not the
Okay.
same?
Unassigned. Yes, miss. Set up protocol, open up.
Here's a hint. Layer 2.
Oh, the protocol.
Nope. What is not the same? Remember, guys, I just said Markivia. Nobody else guessed.
Oh, God. The VLAN ID is not the same. Is that what it is?
Close. What VLAN ID is not the same?
Okay. VLAN ID. I mean, is it VLAN ID 30? That 30 is that the dot?
It's the native VLAN 1.
Ryan, did I just say my key? You guys are terrible. Good Lord.
Yeah.
I like to help, but okay. Okay, so it's the VLAN ID.
Of what?
VLAN ID. Okay, well, right now on the router, the VLAN ID is set to 10. VLAN 10.
What VLAN ID?
What do you mean? The one that's highlighted right there. Like it's set to .110. Now I'm confusing myself.
Okay.
Can I phone a friend?
Nope.
Oh my God.
So let's walk through it. Let's walk through it. Okay. So the issue is at layer 2. Okay. So whenever we configure trunks, okay, one of the criteria is they need to go ahead and agree on what is going to be the VLAN that takes care of untagged traffic that's
man.
not associated with a VLAN, which is the native VLAN. Okay, so hold on, let me finish, please, guys. Don't talk. So if I configured on my router, hey, do router on a stick, but for the sub interface .10, I want VLAN 10 to be my native VLAN, but I didn't reflect that on the switch. I have a mismatch.
Oh, are you talking about oh my God. So you're talking about like where it says status trunking, it says native VLAN set to 1 instead of being set to 10?
Yep.
Oh my God. That is just like right in my face. And I was like, what are you talking about? Oh
It's
my
all
God.
good, guys. It's all good,
I
guys.
can hold it in.
So like why were you saying that we was close when I said VLAN 30? That had nothing to do with VLAN 30 because I was wrong too, right?
So here's why I said you guys were close. Nick specifically said on gigabit 0/0, right? The VLAN, he was getting there. The VLAN for VLAN 10 that he said 20 and 30 is not set. He was getting close.
Oh,
Just had to say native.
It's all
okay.
right.
Okay.
See, that was when I noticed that on this side right here, if you look at where it says the gigabit zeros right under interfaces, where it says 0,
Yeah.
there's all of them have an interface. I mean, sorry, a VLAN ID 10, 20, and 30, but there's no 1. When that was when it dawned on me that I looked on this side, native VLAN 1, but also where it says G00, every last one of them on that side has 1 that's attached to it instead of this side.
Okay. So here's where, when I told you guys, understanding layer 2 and perfecting your knowledge of layer 2, getting as close as possible, is critical before you move to layer 3. Does that make sense?
Yeah, makes sense.
Okay. All right. So let's go ahead and fix this lab, right, and conclude it, right? So to go back to what, PC8, I still can't ping. Things are not working, right? Right? So, of course, I made changes on the right side, but now it's working, right? It's because I went ahead and made that change on the back end, right? But they need to have the same VLAN on both sides, okay? I want everybody to remember that, okay?
Okay, I just have a question. I don't know if that's too in depth, but how do we change the native VLAN on the switch to match? It has to be 10, right?
Yep.
So
So
we do that.
let's do it. Let me move my other screen.
I would like to see that just because it's like,
Oh
why
no,
is
it's all good. It's all good. Let me go ahead and remove my old config on the other screen. Cool. All right. So let me revert that back to the other config. All right. So if I do a show, run interface gigabit 0/0, right? I didn't identify a native VLAN, which means the switch is going to say for this trunk, the native VLAN is VLAN 1. To go ahead and switch that, I need to go ahead and say switch port trunk, right? And let's question mark this out, native, right? Because I want to go ahead and set the native characteristics for when this interface is in a trunking mode, right? So whenever gigabit 0/0 is participating in trunking, and please, whoever's unmuted, please mute yourself, get some feedback. So whenever a port or this port, right, is participating in trunking, I need to say who the native VLAN is, right? So I put my keyword native, right? Then after native, I need to go ahead and put the keyword VLAN, right? And it's telling me what does that VLAN keyword mean? Setting the native VLAN when the interface is in trunking mode, right? So then I get plenty of VLANs to go ahead at my disposal to choose to participate in native VLAN mode, right? So if I configure that to be 10, and if I do that same running config command, okay, there we go, right? So we have native VLAN 10. So if we go ahead and do a show interface trunk, native VLAN 10, right? And we have the native that matches on both sides. Okay.
Thanks for doing that.
Right. Well, I'll make that translated. But does that make sense, guys? Right? Even though R2 is a layer 3 device, once we enable a sub interface, right? As soon as we do that, we're telling this to go ahead and participate in layer 2, right? And what we said at layer 2 for this sub interface is to say, hey, for this trunk that I'm creating with switch 2, go ahead and set the native VLAN to be 10. Okay. Make sense, guys?
Yes, sir.
Okay.
Yes.
All right, guys. On that note, I'll let you guys go chill, and I'll see you guys in 2 weeks.
Sure.
Move.
Later, guys.
Appreciate you,
Appreciate
guys.
that.
Bye,
Thank
guys.
you.